Go ahead, Shay.
Perfect. Thank you so much. Thank you for the invitation, everyone.
Always.
I hope you had a wonderful start of the sessions. I'm sorry I'm joining a little bit late. And it's always a pleasure to come back to Lehigh University and talk to students, interact with panelists. And thank you again for the invitation, Patrick. This is an absolute pleasure. And last year, I had the opportunity to present and talk about some of the things we've been doing here at QuantUniversity. And one of the things which has happened in the last year or so is the explosion of artificial intelligence technologies in the financial services world. And your prior presentation, we looked at algorithmic trading, and we started listening to all these amazing concepts like reinforcement learning and looking at different ways in which you could build out algorithms. Now, I'm going to take a little bit of a different stance on the whole area of artificial intelligence. Of course, there's the opportunity of artificial intelligence, but today I'm going to be talking about the risks of artificial intelligence, especially when you are building out anything. So as financial engineering and quantitative finance students, you always are familiar with the beautiful graph, risk versus reward, right? So you kind of plot out the efficient frontier. You just don't look at the rewards and say, okay, I'm going to just go for the biggest reward. You always look at it from a risk adjusted perspective. So you always balance your risks and rewards. And that's how you kind of, become a good fiduciary and become a responsible financial investor. Now, how do we look at financial models is the big question. When you think about financial services today, if you are amazed with the things in the artificial intelligence world, you got to understand the theory behind, why certain things work really, really well. As you all know, our Siris and Alexas and all the other gadgets have been really, really well in terms of processing our commands. Our robotic vacuum cleaners are cleaning our homes in a perfect way. In the past, it used to just kind of hit the walls and kind of get into a state wherein you had to go in and help it out. And autonomous driving has come a long way. And computer vision applications, whether it's facial recognition or scanning documents or natural language processing. So we've seen some amazing advances in the last few years. But you got to understand that many of these processes have really good, solid ground truth, as they call it, which is the data to train, right? And when you have a lot of good data, if I take a lot of pictures of cats and dogs and build a neural network saying that I want to build a classifier which distinguishes between cats and dogs. Now, cats and dogs, as you all know, you will be able to identify if you see enough number of cats and enough number of dogs. And that's what typically the algorithms do. In the financial services world, it's not as simple as that, because as we all know, there's something called as stationarity in financial services you got to factor in. And history doesn't always repeat itself, as you all know. We don't have the sinusoidal signal or the trending signal, which keeps continuing if you have seen things in the past. And you've also seen that there are things like pandemics, which no one anticipates, which is just going to come and just change the way we think about life and financial assets in general. So that's going to be the context of my today's presentation. Understanding how do we evaluate these algorithms when you are kind of building out interesting things in the context of finance. So let me share my presentation. I hope, Patrick, I will be able to share my screen, I presume. Okay, so I hope you can see my screen. So I call this talk Algorithmic Auditing and Operationalizing Trustworthy AI in Finance with the Q Sandbox, which is the tool I'm going to introduce you to. For people who don't know me, I have been working in the financial services world for close to 15 years now. I started my journey at Citigroup, and then I went to a company called MathWorks, and wherein I led the financial engineering consulting team. And since 2013, I've been running this company called QuantUniversity. We are a data science advisory We focus on the intersection of data science, machine learning, and finance. We do a lot of training programs, educational programs, onboarding programs, and work with companies and also organizations like Premier and the CFA Institute. Alongside, I have a teaching position at Northeastern University here in Boston, wherein I primarily teach courses in fintech and also in machine learning and data science related courses. So every week, I spend at least 7 hours teaching my students on how to build interesting applications in the financial services world. Now, as you all know, the world has changed, and that's where we are thinking about, like, how can companies build responsible AI and operationalize responsible AI? And AI risk is a very new and novel concept. And that's where we are focusing on how do we formalize some of these themes in the context of algorithmic audits, model risk management, and project enablement. So that's kind of what we do. So we recently got invited to be a member of the Linux Foundation of Artificial Intelligence and Data. And they have these principles, as they call them, on what does responsible and trustworthy AI mean. And Linux Foundation, as you all know, is basically a nonprofit organization which supports various open source projects. As you all know, Linux is one of the biggest open source projects, but you also have various Python projects, which are typically in the open source realm. And a lot of companies have been donating the IP of what they've been building in terms of various projects. They've been making it available. So we were invited to be a part of this group, and we hold the weekly meetings. We have multiple organizations, large organizations, talking about some of the issues which we'll have to factor in as we build our trustworthy applications. Now, when you think about, how should we look at artificial intelligence and how do we kind of apply them? If you have been reading the press in the last 6 to 8 months or so, there have been multiple efforts to make AI as not just another technology, but something which all the stakeholders responsibly apply. And that would mean, government agencies, industry. European Union has put out a regulation draft. In the United States, the Federal Reserve and multiple financial services organizations had an RFI for what does AI regulation mean in finance. And then also organizations like NIST, which is the National Institute of Standards and Technology, recently had an RFI, which had like more than 55 respondents on what does AI risk management frameworks mean. So there has been a lot of discussion in the industry and in academia on what does AI risk management mean. And there was a study by the World Economic Forum, and they looked at the various risk management frameworks out there and the AI ethics frameworks out there, and they counted more than 175 of them. And one of the biggest challenges is how do we operationalize it? Because we can always have principles, and we can always say that we are going to be doing certain things and policies in place, but if you do not have an implementation plan, it's going to be very hard for you to actually operationalize responsible AI within the industry. And that's actually required because many of the times, you hear about these artificial intelligence accidents. We've seen in the financial industry, Knight Capital and many other risk management case studies wherein the intent was there to be responsible, but then certain things happened, and then, investors lost money. The financial system stability was questioned, and that's potentially going to happen if we do not, think about artificial intelligence at a design stage and build out various aspects to it. So I'm going to, talk a little bit about like how do we operationalize trustworthy AI, and we kind of take a 3-step approach. And the first approach is through education, because there is a significant skill gap. And as students in the university, I know that there have been a lot of quantitative methods courses, Python-related courses, but also try and make sure that you're understanding it holistically by looking at how do we responsibly adopt artificial intelligence? How do we think about risk management in the context of artificial intelligence? If you look at large consulting companies like McKinsey, PwC, EY, Oliver Wyman, etc., they are building divisions for algorithmic auditing. And we actually trained a whole group of Ernst & Young consultants who are going to be becoming algorithmic auditors and going into companies and auditing artificial intelligence models and certifying them, saying that these models are performing as per design. So this is a growing profession. A lot of companies, if you look at the job boards, are hiring model risk managers and artificial intelligence risk managers. And in the next few years, you will see a whole new career which is going to kind of come up, because you're not only looking at algorithms from the perspective of performance, but you're looking at it holistically on what all it could potentially provide. So I just want to kind of tell a little bit about some of the things we have done to operationalize some of these in the context of algorithmic auditing. And if you look at themes in the world of financial services. So if you're working for, let's say, a large bank, which gives credit cards, now they don't, if they're using a machine learning model to, give you a decision whether you are going to be eligible for a credit card or not, and they have, let's say, a multi-factor model, which, I don't know, 40, 50 different features are going to be looked at. Now, when they're training it, they need to make sure that the model is fair. And fairness means that you got to make sure that all groups are treated equally. If you are going to be training a machine learning algorithm and you do not have data for certain demographics, then obviously for those demographics, the results are going to be very noisy. And as a financial institution, you want to make sure that you are making sure that all these decisions are done fairly and you are giving decisions in a proper manner. But in addition to that, there is a lot of discussion on how do we train these algorithms, right? Because as you know, data becomes the crutch when you work with data-driven algorithms. If you do not have enough variety of data, what you're going to be end up doing is building out generalizers. So in the machine learning sense, if you are going to be working with a lot of different kinds of data sets, you will be looking at, if the situation is such that I have 95% of the population of a particular demographic and 5% of a different demographic, the model is most likely to learn better handling for the 95% rather than the 5%. So a lot of discussion has been happening on how do you test these models? How do you build more robust models? And one of the things is to look at what are called as synthetic data generators. So if you look at synthetic data generation in finance, you're going to see a lot of different ways in which you could generate data. As you know, history has only occurred once, right? So certain things have only occurred once. But if you're going to be projecting for the future, you all know your Monte Carlo simulations. You're going to be, simulating various scenarios, your what-if scenarios, your stress testing scenarios, your scenario generation to make sure that you're factoring all the possibilities of what may happen in the future, right? So in order to facilitate that, if you are building a model with statistical methods, what you typically do is you look at the population, you understand the nuances of the population and build a model which represents the population. And you basically say, okay, if this is what the representation is, I'm going to be doing simulations so that from this particular distribution, if I'm going to be generating data, it's going to be representative of what I may see in the future. In the machine learning sense, machine learning models learn from data, actual records, right? So you need to present it with scenarios which may have happened in the past, true or fake, so that you can potentially learn from what could potentially happen and how do you address those kinds of scenarios. So that's where when you do your auditing, a lot of synthetic data generators are used to simulate scenarios on what could potentially happen and how will the model perform in those kinds of scenarios. And think of it as like, stress testing your model so that you can make sure that the model is robust. And we are creating what's called as a synthetic data hub so that it becomes a marketplace for various synthetic data sets so that you can potentially run various scenario tests and stress tests when you try out various things. And one of the other things to note is this whole notion of anonymity and privacy, because certain data sets may not be shareable outside of your firewalls. And a lot of companies are now thinking about what if we anonymize certain things so that you're not revealing details of how to of certain demographics or populations, and then you're just making data available which has the representative features but may not provide any kind of personal details for various data sets. Now, the other theme which a lot of companies are now looking at are what are called as explainable aspects of artificial intelligence, and that's becoming an extremely important area of research. Now, as you all know, machine learning models are extremely well suited when you do not have, or when they have really, really complex features, and the relationships between these features are very, very intricate. So that's why we use these deep neural networks, right? Because if you build a linear model and we have an assumption that the outcome is directly proportional to a bunch of different features, or even if you kind of start doing iterations and saying, okay, what if it's related to the square of this term, this cube of this term, built-in interaction features. Now you can only go through a whole set of combinations, but that set of combinations is going to explode pretty fast. And that's where deep neural networks comes in, wherein you could just basically provide the structure by saying, okay, here are multiple layers, here are multiple nodes, and these are the various transformations and activation functions, and you can structure the equipment to learn, and then you provide it with data, and the parameters are going to be tuning itself so that you can understand, how to build the functional relationship between your inputs and outputs. The challenge there is you're going to get a beautiful model, potentially very, very complex, millions of parameters potentially, but it's going to be a black box because you won't be able to understand. In regression, as you all know, you can potentially look at the equation and say, oh, my y is directly proportional to x1. And if I increase x1 by 1 unit, whatever is the coefficient of x1 will be the outcomes, will be the contribution of that x1 to the outcome, right? But it's not so simple in black box models because the intricate relationships are so much that you won't be able to draw those kinds of conclusions. So there's a lot of discussion on how do we explain these models? Because one of the things is if I use a very complex neural network model and do a credit decision model, and we tell our clients that, what, I cannot give you a loan, and I can't tell you why, because my model said so, and I don't know what the model thought, and I'm just not going to be able to give you a loan. That's not going to be legal, first of all. Secondly, you'll get a lot of questions. I'm like, well, if you don't understand how your model is working, why are you even using this model? So there's a lot of discussion on how do we make models explainable so that you can understand how the models work. Do we use surrogate models wherein we have a simpler model, which we will potentially be able to use to explain the more complex model? Or are we going to do post hoc explainability, wherein we are going to be looking at the results and seeing if we can explain those results? Or do we build in decision explainable aspects within the algorithms themselves? So there's a lot of open source work and a lot of commercial companies working in this whole area of what is called as explainability, which is also a key factor in the context of algorithmic auditing. Now, one of the things we are trying to do in our world is, as you all know, the theory and the principles need to be operationalized. And that's where we're creating tooling to make algorithmic auditing easier. So we are kind of looking at various facets on what needs to be audited. And we are putting together frameworks and tooling to make sure that you can explain the data and the relationships associated with the various data sets in your model. What kind of models are going to be used potentially if you are going to be looking at multiple models or ensemble models and making a decision for your algorithms. What are the characteristics of each one of these models? What are the pluses and minuses of using these models? Environment is another thing. As you all know, most companies are now running their loads on cloud infrastructures. And what does that mean? It means that you're renting on the cloud and running your models on the cloud, which means that you may have to replicate these environments, because when you say you're renting it, you're renting the space, you're taking all your infrastructure, and you're basically running certain analysis, and then you're shutting down the infrastructure. So you should be able to take exactly what you've been designing into the environment. So the environment matters a lot. And then also the pipelines. As you all know, machine learning models are not just Jupyter notebooks, right? So you don't just basically load a CSV file, run a model, and then run an output. You're going to be looking at multiple data feeds. You're going to be aggregating them. You're going to be cleansing them. You're going to be, doing interesting things with pre-processing of it, trying out different models, doing certain analysis after you build out. So you're building out what are called as pipelines. Think of it as these Ford car, manufacturing pipelines, if you will, wherein you're basically creating a workflow as you're automating various processes. And that's where you gotta understand what is your process and how robust is the process. And then I talked about fairness and explainability. And then you kind of, put the whole thing comprehensively in the context of, the entire application, and then look at the findings and recommendations and report it. One of the other areas which is also becoming more and more important is this whole area of security, machine learning security. As you know, cybersecurity is becoming extremely important for various companies. Machine learning security is another area which is becoming more and more important. So what if somebody steals your model? You're built this amazing model, putting in all this time and effort, and somebody comes in and snoops and sees your model and say, oh, this particular firm is using this particular model for trading. So I can basically now train an alternative model, which can either beat your model or try and create scenarios wherein, if I'm going to be in a situation wherein I can be better by you by only a little bit, my odds of wins are going to be much, much higher. Or what if I can potentially, try and evade certain kinds of attacks, and I could potentially do poisoning your particular models, or looking at various ways in which I could steal certain model parameters. So there are a lot of interesting research angles to it. And security becomes another thing, especially if you are wanting to, you're working with private data sets or working with, personally identifiable information, especially in situations wherein people's information may potentially be used. So that's becoming another important. And as you all know, from a tooling perspective, you have most of the things in your hand. When I was a graduate student, even if I wanted to try out certain things, it was such a big nightmare. First of all, requesting that particular software, getting the software, installing it, trying the whole thing out. And most of my graduate work was more or less just getting all the ducks in a row to make sure that we can actually try out things. And you guys are lucky because in a cloud first world, you can just launch an instance on the cloud and try out any packages or any kinds of tools you want. We have integrated a lot of professional tools in our sandbox. One of the things I would advocate for you guys to think about is get more hands-on experience, and you don't have to do everything on your laptop. Most likely you'll not just be doing everything on your laptop when you go into the professional world. So try and make sure that you attend demos or get access to some of these tools which are in the cloud, so that you could get a comfortable feel on how you use these tools in a professional setting. And lastly, I just want to kind of give you a couple of things to note. Most people just focus on the modeling aspect. I would advocate look at the entire pipeline, because you will have to think about the scraping, the cleansing, the data processing, which needs to be done before you actually build out models. Now, most of the times you feel like that's drudgery. People say, oh, that's something someone else is going to do and give me clean data sets. That's not going to happen in the real world. You are going to be cleansing data sets. And if you do not have the tools and the skills to cleanse your data sets, you're going to be relying on someone else. And that's going to, either increase the time to make decisions, or you may be, limiting your decisions to only certain things because you do not have the required skill sets to cleanse the data. So try and focus on the data sets and make sure you can build out the various things.
Sure, I have a question for you when you're done.
Yeah, so I'll just conclude in a minute. So most of the times, when you're thinking about auditing, there are so many facets to the puzzle, and you would want to make sure that you at least understand from a big picture on how would you test these models before you deploy into production. So think of it as, if you were in the manufacturing world and you manufactured a product and you're going to be selling it to people, what do you need to do to make sure that people are assured that your product is safe? right? Similar things needs to be thought about when you build out these machine learning models, because the risks are many times hidden. And if you do not at upfront kind of build out the infrastructure to make sure that you robustly test them, you're just basically taking the risk of something bad could happen. And when something bad happens, it's going to be really, really, on you kind of a thing. So happy to answer any questions, or if you're interested in a demo or something, please let me know.
So the first one that I have, and you're gonna have to be very brief, less than 4 minutes, but what assumptions do you make about the data in order to generalize it? Do you assume invariance to be drawn from the given distribution, or invariance randomly resampled from the origin in the original data? In either case, how do you ensure that extreme events are reflected in the generalization?
Yeah, that's a great question. I presume this question is coming on the synthetic data front. Mm-hmm. Now, many times, that's where I don't know if we can get into demo mode for a second. But just to give you an idea that many times when you're building out these things, it's extremely hard. And that's where you got to understand your data really, really well. And that's where we look at the various aspects of the data, and then make sure that we understand the important aspects of the data before we even look at interesting things. So what does that mean? So you want to understand the distributions of the variables. You want to understand how much missing value you have, what kind of distributions are you working with. And then when you are building out records, for example, in here, you can see that there is 3.6% of the data missing. So that means, are you going to be cleansing this data, or you're going to be removing this feature altogether? Extremely, when you look at the tails, certain kinds of distributions, you're going to see, some really, some installments which are going to be, in this particular case, really, really sparse. So you'll have to figure out, do I augment it with more information? So think of it as the example I give is if you're calculating the average salary in a university, right? So you don't want to be including the salary of the university president and the management, the management when you're calculating the average salary of the entire university, right? Or you may not want to include the salaries of people who are doing pro bono work, which there'll be a lot of zeros there, right? So you want to kind of understand what distributions you have before you actually simulate the data.
To answer this more specifically, this is Dimitri. Stationarity testing should be done in all financial applications as well. And that's a good way to kind of split your data into different groups and look for those properties, even on weak stationary where your mean invariance is constant across time.
It depends on the data set, and we can have a discussion of, cross-sectional data sets may not have that aspect of stationarity. If you're talking about time series, then it matters, but for cross-sectional, that's not a concern.
Thanks, guys. Okay, thanks for your time, Sri, today. Always interesting. I will this video will be posted, if you don't mind, on the channel, so if people want to refer to it at some later date, they certainly can.
Absolutely. Yeah.
Thank you
so much, Patrick, and it's always a pleasure. Thank you.
See you next year. Bye. Next, we have one of our students, current students in financial engineering math.